Go. Hello and welcome back to Statistics1. This is exam 1 review because in your infinite wisdom you picked to have the exam this Wednesday. In 2 days. All right, the exam is in 2 days. Your quizzes are going. Hopefully you are working on those. And exam is covering chapters 1, 2, and 3. There are about 10 to 12 little sections, and I think you need to memorize only 10 formulas, which is a joke. So we're going to have 10 formulas just in chapter 4, or more than 10 formulas just in chapter 4, which is coming up. This is, I think, 10 formulas over 3 chapters. So I think this exam is really minimum effort as it goes when you compare to the rest. We have, so chapter 1 was terms and words, to learn what is statistics, what is, right? So just the basic stuff. There are no formulas in that chapter whatsoever. You just learned words and definitions. And I put, instead of words, terms and definitions. What is statistics, how to do the random sampling, what is sample, what is population, what is census, and all of these kind of things. So that was all in the first chapter. Chapter 2 is where it started getting interesting, because that's where we had qualitative versus quantitative data. So you will have the problems which would ask you to identify what type of data you have. Then we organized data, and as you organize data, you are looking into all of the ways that include graphical ways, which includes the pie chart and the bar graph and the histogram and stem and leaf and all of the other values, all of the other ways to organize data. So that was for both qualitative and quantitative. So I'll just put both types of data and then list, let's say, frequency table, relative frequency. This table is called the distribution. And then we have histogram. We have bar, graph, pie, chart, stem and leaf, dot plot, and they're all very simple and straightforward. Then we're talking about distribution shapes. So this is where you know that the bell shape and left skew and then right skew, reverse J, and the constant one, those are straightforward. I'll write again. Graphs can be misleading. This was the main sentence. Oh, yes.
Right skew just means the data's heavier on the right side and left skew
Left skewed. No, it's the opposite.
It is?
Yeah.
So right skewed would be the data type.
Because when you draw the okay, so you tell me. I'll have to erase this, but because it doesn't fit here. So what's the first one? Right skewed. So where's the data? There. Yeah. Good. All right, perfect. And that's our chapter 2. Our chapter 3. This is where we go with mean, median, mode, range, sample, standard deviation, 5, number summary. What else do we have there? Well, we had the IQR first, right? It was the IQR, and then upper limit and lower limit, which leads into outliers. We had the box plot, which was the graphical or 5-number summary. And after that, the last lecture introduced population mean, population standard deviation, and z-scores. And technically all of your formulas are in chapter 3. So you have technically 2 chapters of words and categorizing things and sorting stuff. So what is important here? Your sample mean, maybe I should do this mean, let me just change this into a sample mean. There we go. And that's going to be our x bar, which was sum of all values divided by the lowercase n, how many there are. Median was the, I'll call it physical middle. Mode, most frequent data point. You can have more of those. Range was max minus the min. Sample standard deviation was the delightful formula of square root of summation xi minus x bar squared divided by n minus 1. 5-number summary was min, Q1, Q2, Q3, and a max. IQR formula was simply Q3 minus Q1. Upper limit and lower limit I have to write somewhere else. The box plot, that was there. Population mean mu was sum of all observations divided by, now we call it capital N, for, and these two, I mean, we call them as 2 formulas, but it's the same formula. Sample mean, population mean is the same formula, it's the same calculation. It just uses different variables because it represents a different thing, right? Sample mean and population mean are not the same. Population standard deviation, we call that sigma, was the square root of summation of, again, xi minus, now it's mu, squared divided by capital N, no minus 1. Oh, go back to sample standard deviation, put a lowercase s, because lowercase s and the sigma are different. And finally, z-score. What is the z-score measuring? Just say it.
Non-standard deviation away from
Yes. So for any observation, any data point you pick, it measures how many standard deviation that observation is away from the mean. Very good. So that's going to be xi, that's the one you pick, minus the mean divided by the standard deviation sigma. 1, 2, 3, 4, 5, 6, 7 formulas, and then I did not do the these guys yet, so I'll put this blue star over here, and I'll go down. So upper limit, well, let's start the lower limit. So lower limit was Q1 minus 1.5 IQR, and the upper limit is Q3 plus 1.5 IQR, and you know how to find IQR. That's it. This is it. Most of your data falls between 3 standard deviations to the left and to the right. We said 99.7% of your data should fall between 3 standard deviations. That's it. So, yes?
what's the symbol for median?
We just say median. It's Q2. Well, we use a Q2 median of a data because Q1, Q2, and Q3 are all medians. Q1 and Q3 are medians of each half of the data, and Q2 is the median, right, for the entire data. So those are the only ones. There is no letter for it. Even when the book defines it, it says median equals, right? We don't have a symbol for it, other than if you want to use Q2. That's the only thing. With a smile. Good. Yes?
Can you go over Boxplot?
Like draw one and just walk on it, go over. So the box plot is 100% question on your exam because it has to be there, right? Box plot is your graphical representation of the 5-number summary. In order for you to come up with a 5-number summary, you have to have data in order, and then when your data is in order, you are able to say that your minimum is, let's say, 13, that your Q1 is, I don't know, 19, Q2 is 26, Q3 is, I'm just making up data now, 29, and then the max is given as, I don't know, 30? How about 40? How about 39 to make everyone happy? Sounds good? All right. So now I observe this range from 13 to 39, which means that I'm going to, on the number line, make divisions from 10 to 40 to capture all my data, right? Because you want to go below this number and above this number to come up with the good endpoints, right? So we draw our line, and then I'm going to put 10 over here, and then maybe, can I do 5s? No. Let's do 4, 1, 2, 3, 4, 1, 2, 3. Okay, so now I have my values. Each one of these middle, this is my 15, this is my 25, this is my 35. So now I go and I say, okay, where's 13? Well, the first thing we do is the middle, I said. because the first thing we do are those longer lines. So 19 is just before 20. 26 is just after 25. And 29 is just before 30. And then you can connect those. Now, these are the middles, right, that will go out. So we need to find 13 and put the short line. So 13 would be here, and then connect. And then 39 would be here, before 40, and then connect. So here's your min, here's your Q1, Q2, Q3, and a max. This data is normally distributed because this is pretty much symmetric. Now, there was a suggestion to use 30 as a data point. And now I regret that I didn't use it, because your box plot would be using the red line, and then that would represent skewed data. Now I need you to tell me, would it be skewed left or skewed right? I'm just going to keep my poker face, whatever you say, until you give me explanation of why you say that. Okay, so let's forget about skewed left, skewed right. Where's the data? If I'm using the red line, let me erase the black line. If I'm using the red line as the max, where's the data? Is it on the left or the right? On the right. The data is heavy right here, because you have all of this to be clunked together, right? And sorry, Q1, all of this clunked together, and this one would be the one that it's far away. So all of the data would be on the right, which means skewed. Exactly. But so that was if you had that 30 instead of 39. But in this case, everything is symmetric, so this would be one of those bell-shaped, nice distributions. Happy? With a smile? There we go. Now, yes?
Can you also go over standardized variables?
That will be z-scores.
So, I don't know how the mean would always be 0 and standard deviation would always 1.
We are, because mean is 0 standard deviations away from itself. You are always 0 feet away from yourself, because you are yourself. So and remember that mean is just a value on the x-axis, right, of all of the data points. So if the mean is picked, how far is the mean from itself? It's going to be 0 distance. So that's why when you have your data is going to be on the x-axis, and you have the z-score axis. The mean, which is mu, on x-axis would represent immediately a 0 on the z-score. Because if your x is equal to the mean, when you plug it in a formula for a z-score, you get it's x minus mean over sigma, which is mu minus mu over sigma, which is 0 over sigma, which is 0. That's why. And then you have your mu plus 1 standard deviation. There will just be a 1 over here. Mu plus 2 standard deviations would just be 2 on a z-score. And mu plus 3 standard deviations would just give you 3 on a z-score. So your z-scores are generally, they're not always, but they're generally in between a -3 and 3. Because we know that 99.7% of data is in there. But as I said, right, when we looked at the IQ and the Stephen Hawking having 160, there was 4 standard deviations. So it's, right, that percent that it's not 100%. So mean minus standard deviation would be -1. Mu minus 2 standard deviations would be -2. And mean minus 3 standard deviations would be -3. So when you pick a value, it has to fall somewhere like that. So standardized variables are really cool to look at because you're always dealing with the values that are between -3 and 3. Well, vast majority of times you're dealing with those numbers where your data points could be in thousands, right? Let's say the houses, right? Each house is valued at, let's say, 320,000, and then 350,000, and 400,000, and 410,000, right? So instead of dragging those numbers in thousands, you convert them all into the very easy from -3 to 3 values, and you just shovel those instead. They're the same. It's just standardized means you scale it down to -3 to 3, rather than dragging the actual x's. Any other question, concern? Yes.
Go over the random, like the random numbers.
Oh, for random numbers. So since we can't have the computers and Google to ask Google to give us a random number, if I put a question for the random number on the test, there will be a chart from the textbook copied that is attached to your exam, and then you will use that chart to. And as I said, the book showed one of the ways. Then on the homework they ask for a different way, which is okay. We just covered that one way, which is you go down and then you bounce up and then you just snake through, right? So you went down, then you bounce up, and you snake it through like this, right? So that's the only way we're going to use, but you can literally go in any way you want. So if you have those, I'm just going to put some numbers here. And you would pick, and I will start. I will say you have to start with 93. Then you would go down this column, and then you would back up to the next one with the 2 digits inside. And then if you need numbers that are less than 50, you would say 93 rejected, 78 rejected, 31 accepted, 17 accepted, 43 accepted, 55, since I need less than 50, rejected, 56 rejected, right? And that's all it is. Yes. You can have repeating numbers. As I said, you can go in any order you want. So I said less than 50. So we had to reject all of these. Start point given. Because that's for the purposes of test. It's given. Otherwise, you just go and you poke somewhere in the chart, and then that's where you belong or begin. But in all fairness, you will just ask random number generator to generate numbers for you. Yes?
If it asks for like 5 students and it's supposed to represent students, you can't repeat numbers, right? Because then you would have 5.
4, yes. So that's something we are going to deal with that now in chapter 4 with replacement and without replacement. We're going to deal more in depth. So the answer to your question is yes. I would still say don't worry about it, but for now, because you'll be sick of it in chapter 4. Yes?
So we don't go into the column that's right next to the starting point, so where it's like 17, 15, 44.
You can, or you can go to the next group of numbers in the same middle row. which is why you skip that. Okay. Like whatever exercise, if you have one exercise, one homework problem that annoys you per week, if you just skip it, you won't notice. One per week, I said. Oh, actually, hold on. Some of your homework assignments are one problem per section. What am I talking about? You skip one problem, you skip entire section. The way this goes. Who asked about someone asked about standard deviation? Yes. You're about to ask? Okay, do you have a problem for standard deviation?
Yes. Because when I was doing the first question, I referred 0 for the first level of standard deviation, and then I would get the actual answer for the next one, and it went to
Yeah, standard deviation is never 0 because the standard deviation measures the variation in data. So if you have two numbers that are different than each other, right, you are immediately going to have variation in between them, right? So your standard deviation can never be 0 unless your data is just the same number over and over again. 55, 55, 55, 55, 55, 55, 55, 55. There's no variation. The data is just 55 flat. So standard deviation is 0. But as soon as you have two different numbers, right? You can have two different numbers and then another 50 numbers that are the same as one of the other two. Your standard deviation is not going to be 0. It's going to be very, very tiny number, but it won't be 0. Because standard deviation measures the variance in data. That means how different the data points are from each other. And if you recall those basketball teams that we used to explain, their mean was pretty much the same, but then one team had all of the basketball players that were kind of close in heights, and the other one had their mean worked out to be pretty much the same, but the range of the heights was different, so standard deviation was different. So that's what standard deviation measures. It measures the variance in data, and it can't be 0 if your data points are different numbers. So we have to come up. Now, do we have time to compute one? Sure. Let's come up with data of 5 points. That's it. 5-point data. What are the numbers? 1. Nice. All right, what else? That's creative. 4. That was bold. 52. Okay, so 9 first and then 52. We don't have to. Do we expect small or large standard deviation on this one? Large, because look at this, 1 through 9 and then boom, 52. If you guys do your IQRs and everything, look at your IQR is 7. That 52 is the outlier. That 52 is going to get kicked out. But, let's not worry about it. Let's just do these calculations. So first I need the mean. So that's going to be x bar, which is 1 plus 2 plus 4 plus 9 plus 52 divided by 5. So I have 10, and then 62, 64, 68 divided by 5. 5 into 6 goes once, 5 into 18 goes 3 times, and then what's left? 30, so 6. So mean is 13.6. And you see how bad this data is, because look at your mean. 13.6, you have 4 out of 5 values to be below that mean. That was that when you build a castle of $5 million in the neighborhood that all had 300,000 houses, right? So that's that situation. So now we have our xi minus the x bar. If you don't recall the formula, your sample standard deviation is sum of all xi minus x bar squared divided by n minus 1. So we are creating first the parentheses. That's 1 minus 13.6, that's negative 12.6, negative 11.6, negative 9.6, negative 4.6, and then this is 40, 39, 38.4. So these are our values. Now we need to square each one of these. And then at the end, we're going to add them all up. So 12.6 squared is 158.76. 11.6 squared is 134.56. 9.6 squared is 92.16. 4.6 squared is 21.16. And finally 38.4 squared is 1,474.56. All right, so now we add all of these. $134.16 plus 158.16. They add to 1,880.2. So our standard deviation now is at the square root of 1880.2 divided by 4, because it's n minus 1. The number of your sample is only 5, so 5 minus 1 is 4. So we divide this by 4 to get the square root of 470.05, and then we are going to square root this number. It's going to be the same. One of us is definitely wrong, or both, but yeah. So 21.7, standard deviation of 21.7. So you see that this is a really, really bad data, and in this case we would have to kick the 52 value as the outlier. We'll have to kick it out. And then you would, but you know, your question on the exam is, are there any outliers? So you go and you run your IQR calculation, your upper and lower limit calculation, and then you decide whether there are any outliers. So the questions are using the terminology of the class, and if you are not learning the words and you're not making distinction between, you know, the words, then it's a problem. Now, what I suggest to my students, which is you guys now, is to create the list for your formulas, where on one side you're going to have sample, and on the other side you're going to have the population. So you know that lowercase n is the sample size. You're using lowercase n, then you jump to population size. Uppercase n is the population size. Then you go to the left side, you say x bar is the mean, it's the sample mean. On this side, mu is the mean, population mean. Then you have lowercase s for standard deviation. Then you have sigma on population side for standard. So you are learning the proper, right? And then you just go through always keeping, because you will always have in this class, we start in chapter 1, we end in chapter 9, and then you will continue if you go to stats 2. It's always sample versus population. One type of variables for one, The other type of variables for the other calculations between them will either be the same or very similar, right? The difference between the standard deviation formulas is just that -1, right? In the denominator is gone. That's the only, and you use different letters. But it's the same calculation, same steps. So if this was population data, nothing changes other than you put mu here and you will be dividing by 5. Everything else stays the same. So making sure that you have the world of sample and the world of population, one type of variables, right, the letters X bar and S and all that for sample, and then different kind of mu, sigma, capital N for population. The standard deviation formula, it differs only by that -1 and which variables you're going to use, right, mu and capital N. And then z-scores for now are only there for population. Later on in course, we are going to learn t-scores. And t-scores are going to be one with a sample. So we will use S in the calculations. So one thing at a time. The last thing I'm going to say before we end, we still have 5 minutes, so relax, right? Relax. Try not to study on Wednesday. Yeah, I said that. Because what you do is, if you study on Wednesday 5 hours, and then you come to the test, you're going to come here brain dead. Your brain is tired at that point, especially if you didn't sleep last night because you studied all night, because you haven't done anything so far in the class. So you have no sleep night, right? And then you wake up in the morning, and now you're going to study for another 5 hours. Of course, your score is going to be 28 at most, which is, that's just normal thing to do, because do you run before a major? No, right? You relax, you make sure, right? You warm up. You warm up by looking over the formulas, and that's it. Your study time on Wednesday before the test should be 0. 0. You do the quiz on Wednesday. That's one thing you should do on Wednesday. And then look at the formulas just to make sure that you remember all 9 formulas you have for this exam. That's it. That's the Wednesday. So you are not here, right? All because, I mean, I know immediately when you come, oh, I studied. I said, okay, that means nothing. And all these formulas just got confused. Yeah, of course, because you didn't have time to sort them, right? Where they go. So if you make clearly, right, what goes in what basket, right? Socks go here and underwear goes there. Great. You know what's what. And then try not to have a tired brain on Wednesday. You know, good night of sleep. You're refreshed. Leave house early because you're already anxious. You don't want to drive like a maniac for no reason, get in an accident. So all of those things combined will give you much better results than what you might be used to, which is 5 hours of hard study time trying to get somewhere on Wednesday. I hope you also did those practice tests. If you haven't done any of the practice tests, maybe you can do today, at least for chapter 3, because that's the one that has calculations and formulas and everything, just to see where you are, because you still have tomorrow to try and fix some issues if you have any issues. I have 2 office hours to meet you if you have any questions to fix anything. And then Wednesday is the exam. After the exam, depending on if we get to start on time, we might have another very short lecture, just like today, 15 minutes, 20, on events. It is extremely short. We only define some terms. I don't think there are any formulas. There might be one, maybe, I don't know. And then it's a spring break after that. Then I'll see you in 10 days after that Wednesday. Yes. Hour 20. Oh, wait. This class is hour 20. Oh, then there will be no lecture because we can't. Yeah, you're right. I'm used to 2 hours. I'm not used to 3 credit classes. Everything that I teach is either 4 credit or 5 credit class. So I'm really not used to this hour, 20 minutes deal, and I'm always feel rushed. Yes?
How many questions are we going to have on the...
It's going to be, because some questions are very, 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 very quick. Like read something off of the histogram or pie chart or something. So anywhere between 10 and 15. Because this exam really doesn't have any kind of heavy calculations or heavy thinking. You either know or you don't know. There is the standard deviation annoyance, obviously, but it's a pattern, right? So that one will probably take the longest, depending. And again, it's either going to be sample or population, so you just know that the 2 formulas are different by a little bit, and that's it. So you should be okay.
So just look out for the words. You don't need to be able to tell whether it's sample or population.
Yes, because the words, when they say all, right, or entire, or something like that, right, those words give it away that it's population. Generally, when you have a sample, the word sample is spelled out in a problem. A sample of 17 turtles we picked up right on the beach had the mean of blah blah blah, right? Immediately the word sample was in the text, so you get it. Sometimes the text would just, if they don't mention anything but they give you the lowercase n equals 25, lowercase n belongs to the sample size. They give you capital N equals to 25, it's a population, right? And z-score belongs obviously here. T-score will be there eventually in chapter 7 or 8. So you still have ways to go till we get to that one to confuse matters more. See you Wednesday with a smile. A grim over here. It's math class. Be happy.